Okay, so for today's lesson, we're going to be working in Chapter 5, Section 1, Rates and Unit Rates. We have a couple of standards that we'll be addressing in this lesson. Here are our standards, 6RP2 and 6RP3. So this is going to be set very similar to what we do in class. I'll provide some direct instruction, explain things, go over a few things, then there'll be a few moments in this lesson video where I'm going to ask you to pause the video and work the problems, very similar to what we do in class, where I've given you an example or a couple of examples, and then we have problems I have you work on your own, and then after a few minutes we go over those. So it's going to be set up in a very similar fashion as to what we do in class. So when I ask you to pause the video, I do ask that you pause the video, try to work the problems as best you can, then resume the video to see the solution to those problems, just like we do in class. Okay. If you have just a sheet of scratch paper out, since there's no note sheets, that would be very helpful to have out so you can work those problems, or a blank sheet of paper. And then while working on the homework, have this video ready just in case you have to watch different sections to see a worked example. Okay, so here we go. So today we are going to look at rates, and as we learned about ratios, with ratios you can only compare if they're measuring the same thing. Well, rates are a little bit different. So you can use a rate to compare two quantities with different units. So our example here is money and time. Money is measuring wealth, or how much cash you have, whereas time obviously measures hours, minutes, seconds, anything like that. So for example, if May earns $23 in 1 hour, you can use the rate of $23 per hour, or $23 over 1 hour, to describe how much money she earns in 1 hour. And then as you can see there, it can also be written as $23/H, which means $23 per hour. So this is what's known as a unit rate. It's a rate because it's using two different measurement systems, dollars and hours. And it's a unit rate because the $23 is being compared to 1 hour. So a unit rate compares a quantity to 1 unit. So in this case, our 1 hour of a different quantity. So at this moment, this is where you would pause the video. When you are answering, these are yes or no questions. So you are just determining whether or not it's expressed as a unit rate. So pause the video here, answer those 4 questions, and resume when done. Okay, so hopefully you have answered those 4 questions with a simple yes or no to determine if it expresses a unit rate. So for number 1, if we have a monkey that plucked 4 coconuts per minute, let's get this out of the way. Let's go blue today. 4 coconuts per minute. Yes, that is a unit rate because it's 4 coconuts for every 1 minute. Number 2, Gabriella paid $2 for a bottle of orange juice. Yes, that is a unit rate because she's paying $2 for a bottle, or 1 bottle of orange juice. A basketball team scored 294 points in 6 games. No, that is not a unit rate. Neither the points nor are the games down to a unit of 1. You have 294 points, 6 games. Neither of those is 1. And number 4, Joseph reads 3 books in a week. Yes, that is a unit rate because the 3 books are read in 1 week. So again, in order to be a unit rate, it has to be compared to 1 unit of something. Excuse me. All right, so now we're going to figure out how to express a unit rate. Okay? So we have a printer that prints 750 pages in 10 minutes. So I'm just going to simply rewrite 750 pages, and this is an abbreviation for pages, in 10 minutes. Well, when you have a unit rate, you usually want to take the second value. So in this case, 10, we want to take that down to 1 unit. Okay. Well, to get 10 down to 1, we have to divide by 10. And as we've worked with fractions and now with ratios, whatever we do to one term or one part of that, we have to do to the other. So since we're dividing the 10 by 10, we have to divide the 750 by 10. Well, 750 divided by 10 is 75 pages per minute, because 10 divided by 10 would be 1 minute. Okay. Other ways that you can write this answer are 75 pages per minute, and if you want to abbreviate minute to MIN, you can do that as well. Okay. You could say 75 pages in a minute, or you could even take out the word in a, or take out the word a and put in 1, so 75 pages in 1 minute, or you could do 75 pages per minute. Okay. And yes, for establishing a unit rate, you must use proper labels. So yes, labeling will be assessed when we do our formatives. Okay. All right, so at this point, I would like you to pause the video here, work this problem, resume the video when you have a solution. All right, so hopefully you have a solution here. You didn't just keep the video running. If you kept the video running, pause it now and actually work the problem, please. Remember, we want to get that practice in. All right, so hopefully by now you have a solution to check. And we have Kimberly is paid $48 for working 6 hours. How much is Kimberly paid per hour? So again, we have $48 per 6 hours. So again, we want to get that second term down to 1. To get it down to 1, we divide it by itself. And since I'm dividing by 6 there, I need to divide by 6 here. 48 divided by 6 is 8. So it's $8 per hour, or any other way that you have it written. Instead of the slash, if you put per, that's fine. If you put $48 in a hour or in 1 hour, that's fine. If you have $8 over an hour, that's fine as well. A school buys 2.75 acres of land for a new athletic field. What is the cost per acre if the school pays $275,000 for the land? Okay. A key word in these is the word per. And if you can find the word per in the question, that'll help you set up your rate. Okay. So since this is cost per acre, we want to put the cost first. So the cost is our $275,000 per, or in this case, I'm going to use the word for. They could be interchangeable in this situation. And then our acre is 2.75 acres. So if I'm looking for the cost per acre, that means I want the cost per 1 acre. So again, I'm going to take this second one down to 1, and the way you take it down to 1 is, again, you divide it by itself. So if I'm taking $275,000, I also have to divide that by 2.75. Well, once again, we're dividing by a decimal, and we have worked with decimals before. Okay, but again, if needed, we can do that work off to the side. So the 2.75 is my divisor. 275,000 is my dividend. Remember to move the decimal point to the end of your divisor. And then we need to move our decimal point, which in this case is going to come after the 275,000. We put those two zeros on. We move that two places. The 2.75 is now 275. And the 275,000 is now 27,500,000. Well, 275 goes into 275 once. We get 0, and then we bring these 5 zeros up. So we get an answer of $100,000 per acre. Excuse me. All right, so you have two problems here to work on. Let's slide that down a little bit so you can see it a little bit better. So if you would please go ahead and pause the video here, take a couple minutes, work on those two, and once you have answers, go ahead and resume playback of the video. All right, well again, hopefully you have taken the time to work through those problems, have some sort of answer down, at least made an attempt, tried something, and we will take a look at those now. If you haven't, again, pause the video, work the problems before you resume playback. All right, let's use some purple for this one. What do you say? All right. A sports center buys 1.25 acres of land for a new swimming complex. Again, we have the cost per, slide the finger down, slide that down out of the way. So there's the word per, we want cost per acre. So we have $100,000 for 1.25 acres. So again, I want to get that second unit down to 1, so I'm going to divide by 1.25, which means I have to divide by 1.25. So I have 1.25 going into 100,000. So just like in the example, I move the decimal point to the end of my divisor. I move it two places in my dividend. The 1.25 is now 125. The 100,000 is now 10 million. Hmm. 125 will not go into 1 or 10 or 100, but it will go into 1,000. So way back in the beginning of the year, one of the strategies that we went over for division was to make a guess and see what happens. Okay? So you might think that 125 goes into 1,000 6 times. Spoiler alert, it doesn't. But you would do your work and you would see what happens. Oh, that's 750. That's going to be too low. So you'd want to choose a higher number, and maybe you try 8. Spoiler alert, 8 does work. So 40, 16, 20, 8, 10. Hey, look at that. We get 0. We bring these 4 zeros up, and we get an answer of $80,000 per acre. Okay. And again, if at any time I go too quickly as you write stuff down, pause the video so you can get that work down, or rewind it a little bit to hear the explanation again. All right, I'm going to extend the page a little bit so I can see this one and have a little bit of room to work. A few years ago, when the fuel tank in Jayla's car was completely empty, she paid $63 to fill the tank with 22.5 gallons of gasoline. What was the cost per gallon? So cost is $63. Our gallon is 22.5. So again, we want to divide that second number by itself, which means we divide the 63 by 22.5. Move the decimal point, move the decimal point. Excuse me. Okay. Another strategy that we had was to look at just the first digit of each number. So the first digit of 225 is 2. The first digit of 630 is 6. And we can start with that. And we know that 2 goes into 6 3 times, so maybe we try 3. We do our multiplication. And we see that 675 is going to be too high, which means it will go in 2 times. 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5. 2 times 2 is 4. Oops, there's no 1 there. It's like, why, that doesn't work. 2 times 2 is 4. We do our subtraction, 0 minus 0 is 0. We have to do some borrowing here. 13 minus 5 is 8. 5 minus 4 is 1. Okay, we've run out of digits, so when we were dividing decimals, remember you can put a decimal point and a 0 on, bring that decimal point up into your answer, bring the 0 down. Okay, well, the 2 would go into 18 9 times. So if we use some recent events, we knew that 2 went into 6 3 times, but 3 was too high. So if 2 goes into 18 9 times, 9 is probably too high, so instead of trying 9, it might be a good idea to try 8. 8 times 5 is 40. 8 times 2 is 16, plus 4 is 20. 8 times 2 is 16, plus 2 is 18. And it does happen to work nicely. However, when we write our answer, remember we are dealing with money. Money goes out to the hundredths. So you would want to put $2.80 per gallon. This table shows the cost of some fruit purchased at a farm stand. So we want to figure out which fruit costs the most per pound. Well, in order to figure out how much it costs per pound, or which one is let's try that again. To figure out which fruit costs the most per pound, we need to get its cost per pound. Now, something you have to be very careful of with this table is it's asking for the cost per pound. Well, the cost is actually here, and the per pound is right there. So we do have to make sure that we are using the numbers in the right order. So to get the cost of the mango, we're going to take $2.60 divided by 2. That's pretty straightforward to do. 2 divided by 2 is 1, 6 divided by 2 is 3, and 0 divided by 2 is 0. So we know that that's going to cost us $1.30 per pound. For the pear, we are going to have to do a little bit more work for that. So I know on the outside I'm going to have 250, but I'm going to go ahead and move my decimal points. And we'll just put a couple of those in here. Excuse me. 25 goes into 35 once. I get 10. Bring the 100 down, or bring the 0 down. Make that 100. Bring the decimal point up. 25 goes into 100 4 times. And then bring that 0 up. So it's $1.40. And then the orange, we'll again do our division. Again, I'm going to move my decimal points already. I moved it twice on 2.25, so I got to move it twice in the 270. 225 goes into 270 once. subtraction. 10 minus 5 is 5. 6 minus 2 is 4. 2 minus 2 is 0. Decimal point up, 0 down, and it goes in 2 times. And then since we're dealing with money, it would be $1.20. So, which fruit costs the most per pound? Well, the most per pound is the pear. At $1.40. All right, go ahead and pause the video here. Work this problem, and when you have the 3 costs per pound filled in, and you've determined which costs the most, resume playback. All right, hopefully you have found the cost per pound of each vegetable and are ready to go. All right, so for the potato, if we want the cost per pound, we're going to take $4 and divide it by 5. Well, 5 doesn't go into 4, it'll go into 40 8 times. So we get an answer of 80 cents, or if you have $0.80, that's fine. Carrots are $3. We bought 5 pounds of carrots. Goes into 3 0 times, goes into 36 times. So we get 60 cents per pound. And then the onion, we bought 2 pounds. It's $2.50. Goes in once. Goes in twice. Oops. Forgot to bring the 5 down. And it goes in 5 times. Sorry, I can't finish. I'm going to run out of room there. So we have the onion at $1.25. So which type of food costs the most per pound? It is the onion. And then finally, just a few situations here where you would use a unit rate. So electrical consumption is measured in kilowatt hours. The Harris family used 350 kilowatt hours of electricity in April. The cost of electricity is 12 cents per kilowatt hour. At this rate, how much did the Harris family pay for the electricity used in April? Okay. Well, if it's 12 cents per kilowatt hour, that means we're dealing with 1 kilowatt hour. And they use 350 kilowatt hours. Well, to get from 1 kilowatt hour to 350, you would have to multiply by 350, which means we have to take the 12 cents and multiply it by 350. So let's take our 350 times our 12 cents, and so I'm going to rewrite 12 cents appropriately. Okay, 0.12, 2 times 0 is 0, 2 times 5 is 10, 2 times 3 is 6, plus 1 is 7, start the second line with a 0, 1 times 0, 1 times 5, 1 times 3, add those together, 0, 0, 12, 4, no digits behind the decimal point, 2 digits behind the decimal point for a total of 2. So, how much did the Harris family pay? $42. The pool is filled at a rate of 150 liters per hour. And we want to get 750 liters of water. So 750 goes here. we just had to figure out how many 150s there are in 750. Well, 150 times 5 is 750. So we take our hours times 5, which means we get an answer of 5 hours. And again, when we're working with rates, you must label your answers. Dollar signs count as labels, or putting hours. You can abbreviate. That's fine as well. All right, so these will be the last ones for you to practice on your own in the lesson. So go ahead and pause the video here. Work these last 2 questions, and then we'll go over. All right, well, hopefully you have paused and have gotten a couple answers here. Let's see what the answer should be. So water flows from a faucet at a rate of 10 liters per minute. At this rate, how many liters of water flows from the faucet in 4 minutes? So 10 liters per minute. We go for 4 minutes. Well, to get from 1 minute to 4 minutes, you have to multiply it by 4. So you take the 10 and multiply it by 4, and you would get an answer of 40 liters. Apples were sold at $3 per kilogram. At this rate, how many kilograms of apples did Quan buy with $21? So it's $3 per kilogram. To get to $21, you've got to multiply 3 by 7. So you multiply your kilograms by 7. So you get an answer of 7 kilograms. All right, and that is all for today's lesson. Please check your email, your Canvas announcement to see which problems out of the extra practice and homework book, and we're still in book A, that you are assigned to do. If you have any questions, do not hesitate to email me and I will get back to you as soon as I can. All right, that's it for today's lesson. We'll see you soon.